Hi, Math 2 kiddos. All right, so we are going to go ahead and keep rocking and rolling through this packet here. All right, so the next kind of problems you're going to have to know how to do are word problems with Pythagorean theorem. They're not too bad. So first off, one thing you should know is like with a right triangle, we have, it doesn't look like a right triangle. We can fix that. There we go. These guys are the legs. Remember that the legs make the L, make the 90-degree angle. They're the A and the B. And then this is the hypotenuse. All right. So, right, they tell us here that one of the legs measures 4, so we could put a 4 here. And the hypotenuse measures 16, and they want us to find the other leg. So that's like our X, or we could just say like it's our B, whatever. So we can say 4 squared plus B squared equals 16 squared. So we get 16 plus B squared equals 256. And I'm just going to use my calculator for that. 256 minus 16 gives me 240. So B squared equals 240. And then I'm going to go ahead and take the square root of both sides. Again, with Pythagorean theorem, you don't have to, in this case, right, you don't have to do plus minus. So keep that in mind. But anyhow, you end up with square root of 240 is 15, and they want us to run to the nearest 10, so we'll do 15.5. All right, next one. So it says graph a right triangle with these points and form the hypotenuse. Using the sides, find the distance. So one kind of important thing to know is that Pythagorean theorem can be used to find the shortest distance between 2 points. So all you need to do here is graph these points and then connect them and make a triangle. All right. So we could see here that this guy is 4. We could see here that this guy's what, 1, 2, 3, 4, 5, 6, 7, 8. This guy's 8. So we could use Pythagorean theorem here. So we've got 4, 8, and then we have to find our hypotenuse here. So the hypotenuse you can't count because you see how like it's on a diagonal. You have to use Pythagorean theorem for that. So we're going to do 4 squared plus 8 squared equals c squared. So that's going to be 16 plus 64, and we get 80. Now in this case, they want it in simplest radical form, so we have to make sure that we simplify the radical here. So the square root of 80, we should break down, let's see, definitely a 4 would go in there. We could go higher. Is 16 go into 80? Yeah, so we want to break 80 down into 16 times 5. All right, so we get 4 root 5. So that's our hypotenuse, 4 root 5. Remember to pay attention if they want it in simplest radical form or if they want it in decimal form. All right, it depends on the problem. All right, so let's go ahead and try this one. Same deal. We go 2. We go 1, 2, 3, 4, 5. So we're going to do 5 squared plus 2 squared equals c squared. So we get 25 plus 4. And I got 29 equals c squared. So then c is going to equal the square root of 29. Now, again, they want simplest radical form. You can't break down root 29. 29 is prime, so it's literally just going to be root 29. All right? All right, next problem. So for these, some of them you have to do Pythagorean theorem multiple times. All right? Now, in the intermediate step, just leave your answer in radical form. You don't even have to simplify it, but don't round. So I'll kind of show you what I mean there. All right, so what they're doing is they're asking for this length here. So first, we're going to use this triangle and figure out this side because we need that side to solve for x. So we're going to go ahead. We've got 7 squared plus, I don't know, we can call this b, plus b squared equals 10 squared. So we're going to end up with 100 minus 49. So we know that b squared is going to give us 51. So b is equal to the square root of 51. So like I said, just leave this side in radical form. Do not round it. So we're going to leave this as the square root of 51. All right. So now we're going to go ahead and do Pythagorean theorem on this second triangle here. So we can say that 3 squared plus x squared is going to give us the square root of 51 squared. So 3 squared is 9. The square root of 51 squared is just 51. Whenever you square just a radical, the radical goes away. So then we're going to get 51 minus 9. If it lets me do it, there we go. 51 minus 9. And we get 42. So we get x squared equals 42. So we get that x is going to be equal to the square root of 42. And let's see, I don't know, can we break that down? 42, I don't know about that one. Let's see, 42, I don't think any, no, 42, 16, 25, 36. Yeah, so actually we cannot break down the square root of 42. So that's an interesting one. So that's our answer here, is root 42. All right. Okay, let's keep rocking and rolling here. So the next problem, this is again a two-step Pythagorean theorem. So first we got to find this guy. We'll call this guy B, and then we're going to use B to find x. So we're going to do 7 squared plus 10 squared equals B squared, or actually we'll call that C, I guess it would make more sense in terms of the Pythagorean theorem, right? So we get 49 plus 100, which is going to be 149. So we get square root of 149 right here. All right. So now we can go ahead and do Pythagorean theorem on our second triangle. So we're going to do the square root of 149 squared plus 8 squared equals x squared. So that gives us 149 plus 64. All right. So 149 plus 64 is 213. All right, and then we take the square root. So that's our answer, and of course we have to see if we could simplify that. So let's see. Any of these go in there? 213 divided by 64. 213. I don't know. I don't think anything's going to go into here nicely, but we could try. I don't know if this is a prime number. Let's see, we get 36, 213 divided by, obviously 25 isn't going to work, 16, 213 divided by 9, 213 divided by 4. No, nothing works, so it looks like our answer here is just going to be this. All right. All right, next one. So now, whenever you have like a word problem, you want to draw a picture. All right, don't just do it all in your head. Draw a picture for it. So here we can go ahead. It says we have a ladder against the top of a building, and the bottom of the ladder is 33 feet from the bottom of the building. So the ladder is 39 feet. So, right, if this is like our ladder here, we can put a 39 there. All right. And then the bottom of the ladder is 33 feet from the base of the building. So this is what we need to find. Okay, they want to know how tall the building is. So we're going to do 33 squared plus b squared equals 39 squared. 39 squared is 1,521. 33 squared is 1089. So we're going to do this guy minus this guy. And we get 432 equals b squared. Take the square root, we get the square root of 432. Now, do they want, they just want decimal nearest tenth. So we just got to take the square root, which is going to be 20.8. All right. All right, number 17 here, another word problem. So with directions, you want to kind of keep in mind, hopefully you know north, east, south, west, never eat soggy waffles, never eat soggy wheat, something like that. All right, so it says you start driving west for 8 miles. So let's go west 8 miles, and then you turn left and you drive south for another 11 miles. All right, so we got 8 miles this way, 11 miles this way. And they want to know, from a straight line, you're starting to your ending point, so we're just finding the hypotenuse there. So you're going to do 8 squared plus 11 squared equals c squared. So that's going to be 64 plus 121, which gives me 185. All right, so the square root of 185 is going to be my length, and they just want a decimal answer again, which gives us 13.6. All right, last one here. So first off, it says an altitude is drawn from the vertex of an isosceles triangle. So first off, what is going on here? So an isosceles triangle, we've got two sides the same, right? And an altitude is going to go right down to here and make a 90-degree angle. That's what an altitude of a triangle is. So forming a right angle with two congruent triangles. As a result, the altitude cuts the base into two equal segments. So that means that this is cut directly in half. All right. The length of the altitude, so that's this guy here, is 25 inches. And the length of the base, which is this entire guy here, is 20. So if this entire guy is 20, clearly this altitude, right, cuts it in half. It makes two equal segments. So this guy would be 10. And it says find the triangle's perimeter. So we need to find the hypotenuse right here. So we can do 10 squared plus 25 squared. And we get 725. And that's going to give me my hypotenuse squared. And we take the square root of 725. And again, they just want us to round. So that is going to be 26, or actually, I lied to you. We're not going to round to the very end. I'm sorry. So C is going to be equal to the square root of 725. So we're not done yet. So let's just put that in as root 725. You could simplify this, but we don't have to because we're looking for a decimal answer anyway. So now they ask for the perimeter. So we know that this side is root 725. This side is also root 725. And this bottom part is 20. So to find the perimeter of the triangle, we just need to add them all up. So we're going to go root 725 plus the square root of 725 plus 20. And that gives me 73.9.